When you run complex IT infrastructure without visibility, you're flying blind. A single overloaded drive or a silent memory failure can cause an entire rack of systems to go dark without a single warning. Today, we are going to fix that. We'll link two completely different types of hardware into a central monitoring hub to see exactly how they are performing. Specifically, we'll pull metrics from a closed network storage appliance and a standard Linux server. To follow along, you will need an active Zabbix server already running on your network. Establishing these links moves your hardware out of the shadows and provides a constant stream of health data that alerts you before a critical failure occurs. Before we touch the hardware, we need to understand how Zabbix handles incoming data. You should never manually configure individual sensors for every new device. Instead, we use templates. These pre-packaged configurations scan your device automatically. If you plug in new equipment, the template identifies hard drives or CPUs and applies predefined safety thresholds. If a drive hits 90% capacity, the alert trigger is already set. This reduces hours of manual data entry into a single drop-down selection for every new device you bring online. Our first target is a closed storage appliance, like a Synology NAS. On these devices, we cannot install custom third-party software directly onto the operating system. For closed hardware, we rely on SNMP. It is a universal protocol used to extract data from devices that don't allow agent installations. Log into your appliance's control panel and enable the SNMP service. For the best security, select version 3. Right below that setting, create a simple username and authentication password. Keep these handy, as we'll need them in the Zabbix interface. Apply those settings, then open up your main Zabbix dashboard to initiate the pairing process. Click Create Host. Give your appliance a name. Input its local IP address under the SNMP interface section, and assign the corresponding template for your brand of NAS. Finally, scroll to the Security section and enter the exact SNMP username and password you just created on the appliance. SNMP allows you to pull deep operational data from proprietary hardware while staying within the manufacturer's software restrictions. Now we'll look at a standard Linux server. Because this is an open environment, we can install software directly to get more granular data. SSH into your server, download the Zabbix package, and use the terminal to install the agent. We are configuring an active agent. Instead of the hub requesting info, the server pushes its data outward. Open the configuration file, find the server active variable, and point this to the IP address of your Zabbix server. You also need to define the local machine's hostname within this same file. Save your changes and restart the agent. Next, check the firewall on your Zabbix hub. You must have port 10,051 open, or the incoming data packets will be blocked. Back in the Zabbix web interface, create a new host and select the active agent version of the Linux template. Ensure the host name you enter in the Zabbix interface is an exact match for the name you wrote in the server's configuration file. If the text doesn't match perfectly, the hub won't recognize the data. This active architecture is ideal for monitoring servers sitting behind strict firewalls, or those with IP addresses that change frequently. When you first add these devices, the dashboard may remain empty. By default, discovery rules run on a spaced-out schedule to keep resource usage low. To see your data immediately, go to the discovery rules for your new host, select them, and click Execute Now. After a minute, navigate to the Latest Data section to verify the new telemetry is arriving. You can now see live graphs for CPU load, network throughput, and disk capacity. All of this was populated automatically by the templates we selected. If you check the Triggers tab, you'll see that Zabbix is already monitoring these metrics for any signs of trouble. By following these two connection methods, you've standardized how you bring new hardware into your monitoring environment, turning unknown system states into actionable data.